So this next video will deal with solving right triangles. All right. The last video we just were looking at the 6 trig functions of the angles in the right triangle. Now here we're actually going to use trig functions to solve right triangles. Now all this really means is that if we're given one angle in a right triangle and one side in a right triangle, right, regardless of whether that side is a leg or the hypotenuse, we'll be able to use our trig functions to find the measures of the other angles and the lengths of the other sides. Now really there's only going to be one other angle because we know it's a right triangle, so we're going to be given one acute angle and we'll just find the other acute angle. That's easy. And then we'll have to find the lengths of the two other sides. Okay, and that's where we're going to have to use the trig functions when we find the lengths of the other two sides. Okay, so the first example here, they tell us suppose that side A, right, leg A equals 9 inches and angle B equals pi over 5, right? This is in radians now instead of degree measure. So what I would do first probably is just draw my right triangle. And it doesn't really have to be to scale. It doesn't matter. So that would be my right angle. And again, my right angle is always going to be called C. And then I can choose. I can have this be A or B. I'll just call this A. And then that forces this to be B, which now means that the leg that's opposite angle A will be little side A. The leg that's opposite angle B will be little side B. And of course, the hypotenuse is going to be little c. Okay? So in this case, what do I know? I know that little a, which is right here, equals 9. And I know that this angle B is pi over 5 radians. All right? So the easiest thing really to do first is realize that, well, the two angles, angle A plus angle B, have to equal 90 degrees, which in terms of radians is really pi over 2 radians. So if I know that angle B is pi over 5, angle A is just going to be pi over 2 minus pi over 5, right? Now, if this was in degrees, it would be a little bit easier, but it's just a matter of, getting common denominators and stuff. So pi over 2 is really 5 pi over 10, and pi over 5 is really 2 pi over 10. So this is really 5 pi over 10 minus 2 pi over 10, which is going to be 3 pi over 10. So we have one of the three things that we need, right? We needed to find the other angle and the two other sides. So we found the other angle first because that was the easiest thing to do. Okay? So now we need to find side B and side C. So first, let's say we're trying to find side B, right? So we're going to try to find side B using side A, which was 9, and angle B, which was pi over 5. So what you have to first do is ask yourself, in relation to angle B, right, what is side B, right? Side B is actually the opposite, right? And in relation to angle B, what is the 9? The 9 would be the adjacent, right? So which of our trig functions, sine, cosine, or tangent, involves the opposite and the adjacent? Well, it's SOHCAHTOA, right? So the one that involves the opposite and the adjacent is the tangent. So what I'm going to have to do to find side B is use the tangent, right? So what I'm going to do is I'm going to say, well, what is the definition of the tangent of B? The tangent of B is going to be the opposite over the adjacent. So the tangent of B is pi over 5, so I'm really doing the tangent of pi over 5, and this has got to be equal to the side opposite, right, which is B, which is what I'm trying to find, over the side adjacent, which is 9. So I have the tangent of pi over 5 equals B over 9. And really, this is just now a simple equation to solve, right? Because you have to realize that the tangent of pi over 5 is just a single value, right? I'm going to have to, get it using the calculator, but it's just a single value. The tangent of pi over 5 is some number, right? Some ratio. So, and that's equal to B over 9. So if I want to solve this for B, all I'd have to do is multiply both sides by 9. So then I would have the fact that b equals 9 times the tangent of pi over 5. And now, of course, that's my exact answer. But if I want to get an approximation for this, I'm going to have to put it into the calculator, right? So I would just go to my calculator, open up my calculator here, and just say, all right, well, make sure first that I'm in the correct mode, right? I have to be in radian mode, which I am, right? So go back to my home screen, and I just do 9, and then tan, and then just enter the angle in as pi divided by 5. So that's it, 9 times the tangent of pi over 5, and this will give me 6.54, right? I mean, it depends on how many decimal places you want to round to, but let's say we'll go 2 decimal places, so I'll say this is 6.54, and A was measured in inches, so this is going to be measured in inches as well, right? So now I have one of my sides, which would be side B, which is 6.54 inches. Okay, so I found one of the sides and the other angle. Now all I need to do is find the last side, which in this case would be the hypotenuse, which is C. Okay, now what some people are going to tell you to do at this point is they're going to say, all right, well, now that I have two of the sides, I can just use the Pythagorean theorem. Yeah, you can, but the problem is 6.54 is not an exact value, so then I'd be using a rounded value, and it would throw things off a little bit. So if I want to have a more precise answer, I'm still going to keep using what was given to me originally. And what was given to me originally was the angle B and the side A, right? So now I'm going to do what I did before. I'm going to ask myself, all right, well, in relation to angle B, what is C? Well, C is the hypotenuse. And what is 9 in relation to angle B? 9 was the adjacent. So what's involved in finding this value of C? The hypotenuse and the adjacent. So which trig function involves the hypotenuse and the adjacent? Well, that's the k part of SOHCAHTOA, which would be the cosine, right? So before I was involving the opposite and the adjacent, so that's why I used tangent when I was finding side B. But now to find side C, I'm using the adjacent and the hypotenuse, so I'm going to use the cosine. So it's going to be a similar setup, though. I'm going to say that the cosine of B is going to equal the adjacent over the hypotenuse, right? I'm running out of space here a little bit, so I apologize in advance. So again, B was pi over 5, so I'm going to say the cosine of pi over 5 is equal to the adjacent, which I know is 9, over the hypotenuse, which is the thing that I'm trying to find, which is C, right? So cosine of pi over 5 equals 9 divided by C. And what's really going to have to happen here is I'm going to have to basically cross multiply and then divide by the cosine of pi over 5, right? So if I took this equation here, cosine pi over 5 equals 9 over C, and cross multiplied it, I would have C times the cosine of pi over 5 equals 9, right? Because again, what you can do is you can look at this cosine of pi over 5 as being cosine pi over 5 over 1, and then I can see how I can cross multiply there, right? This times this equals 9 times 1. And now that I have this, I would just divide both sides by the cosine of pi over 5, so I know that C is 9 divided by the cosine of pi over 5. And again, this is my exact answer. 9 divided by cosine of pi over 5 is my exact answer, but of course if I want to approximate it, I'm going to put it into the calculator, and I'm going to say, all right, well, what's 9 divided by the cosine of pi divided by 5? And that would give me 11.12, let's say, right? So it's approximately 11.12 inches. So now I'm finished. What I've done now is I've solved this right triangle. I found the other angle, which was 3 pi over 10, the other leg, which was 6.54 inches, and then the hypotenuse, which was 11.12 inches. Okay? So what I can also do with this at the end as kind of like a check is make sure that this works with the Pythagorean theorem, right? So if I do a squared plus b squared equals c squared, the a squared plus b squared should be the same as c squared. So in this case, a was 9. So if I do 9 squared, and b I found to be approximately 6.54. So if I do 9 squared plus 6.54 squared, I get 123.7716. Again, this is an approximate answer. It's not exact. And then if I do c squared, c was 11.12. I get almost exactly the same value, right? It's very close, and the fact that it's very close is a good thing, because that tells me that I probably solved my right triangle correctly, because a right triangle should always satisfy the Pythagorean theorem, and I showed here that it basically does, right? It's not exact, but it's very close, and the reason that it's not exact is because I use rounded values, okay? But close enough because I use rounded values, all right? So this would be my solved triangle, right? Angle A is 3 pi over 10, side B is 6.54 inches, and side C was 11.12 inches. So I'm going to do one more example now of solving a right triangle. Now in this case, we're given side C, which is the hypotenuse, and angle A, which is 25 degrees. But again, I can just draw any old right triangle that I want to. And again, I'm going to call this the right angle, so this is C. And then I can call this angle here A, and this angle here B, which then again forces that to be little a, this to be little b, and this to be little c. Okay? Because again, that has to always be the setup for the right triangle, right? Side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Okay? So here I know that side C, which is the hypotenuse, is 21 centimeters, and angle A I know is 25 degrees. Okay? So now in this case, again, the easiest thing to do is just find the other angle first. So I know that angle A and angle B have to add up to 90 degrees. So what is angle B going to equal? It's just going to equal 90 minus 25. All right? So angle B is going to be 65 degrees. So that's the easy part, right? Finding the other angle is always the easiest part. Just subtract from 90 or subtract from pi over 2, regardless, whether it's in degrees or radians. Okay. So now let's say I want to find side A, right? We'll start with A. So again, I'm going to use my given info. So my given info is 25 degrees and 21 centimeters for C. So in relation to 25 degrees, A would be the opposite, right? The leg opposite. And 21 is, of course, the hypotenuse. So which of my trig functions involves the opposite and the hypotenuse? Well, again, remember, SOHCAHTOA. So this is the SO part. So it's going to be the sine. So in order to find side A, I'm going to use the sine of A, right, which is 25 degrees. I mean, I could have written sine of 25 degrees here if I wanted to. But it's going to be the sine of angle A, which is going to equal the opposite, which is side A, which is the unknown, over the hypotenuse, which is 21. So it's just the sine of 25 degrees equals A over 21. And just as I did in my last example, now to solve this, I'm going to have to multiply both sides by 21. So there's my exact answer, right? My exact answer is just A equals 21 sine of 25 degrees. But again, I'm going to want an approximation, of course, so I'll go to my calculator, but now this time I'm dealing with degrees, so I'm going to have to go and turn this into degree mode, right? So hit enter there, so degree is highlighted, and now when I do 21 sine 25, I'm going to get 8.87, and 8.87 is in centimeters, and this is my side A. So side A is 8.87 centimeters. So I found side A. Now I just need to find side B. So same thing as before, when I find side B, I'm going to ask myself, well, in relation to 25 degrees, B would be the side adjacent, right, because it's next to angle A. And of course, again, C is the hypotenuse. So which of my trig functions involves adjacent and hypotenuse? So that's the k part of SOHCAHTOA, which would be the cosine, right? So I'm going to have the cosine of 25 degrees, and this is going to equal the adjacent, which is B, over the hypotenuse, which is 21. And again, the nice thing here is I just have to multiply both sides again by 21. So I have the fact that B equals 21 times the cosine of 25 degrees. And that's my exact answer. But of course, again, I want an approximation. So I'm going to do similar calculation, but now it's 21 cosine of 25. And this equals 19.03. So this is 19.03 centimeters. So that would be my side B. Okay? And then just another thing that you can do, I mean, I'll do the check on the calculator with the Pythagorean theorem in a second, but you should just verify that the biggest side is opposite the biggest angle and the small side is opposite the smallest angle. So the hypotenuse is always going to be the biggest side. So hopefully 21 is bigger than the other two sides that I found. So 21 is bigger than 8.87 and 19.03. So that's good. And then side B should be the next biggest because it should be opposite the 65-degree angle, right? So side B is opposite the 65-degree angle, so it should be the next biggest side, and it is. It's 19.03. And then A should be the smallest side because it's opposite the smallest angle, right? So A is indeed the smallest side. It's 8.87. Okay, so that's another way to do kind of like a, you know, a semi-check, right? You're not doing like a full check there. You're doing like a semi-check. Now, to do a more rigorous check, you can actually use Pythagorean theorem and just make sure that if you do 8.87 squared and add it to 19.03 squared, that's A squared plus B squared, right? Make sure that that is at least close to C squared, which is 21 squared. And yeah, it's very close, right? It's within 2/10, right? 440.8178 and 441. So it's pretty close. So I can be pretty confident that I solved that triangle correctly. Okay? So it's always finding three things when you're solving these right triangles, right? You're finding the other acute angle, which you just get by subtracting from 90 degrees or from pi over 2 if it's in radian measure. And then the other two sides, which you find by using trig functions.